So we have started cross product in the last class or vector product in the last class. Okay. Okay. How did it go? How was maths? Okay, cool. Okay, so we are starting with the last topic of vector algebra, which will be cross product or vector product. We can use any term, right? Just a minute. Okay, so we are starting with cross product today, and we know that another name for this is vector product as well. And why vector product? Because the output of this product is a vector quantity, right? The output of this product is a vector quantity, and that is why we name this as vector product. And we have written these few things, but because Faiza, Shahid, and yeah, Faiza and Shahid left the class early, so I'm writing this again. Just these basic things. And by the way, Tharif and Chavez has, I think, have already noted this down. So you guys can just revise this quickly. So let's say consider two vectors A and B, right? Consider two vectors, A vector and B vector. In that case, their cross product or their vector product can be written like this, right? This is the cross product or vector product of two vectors A and B, right? And we read it like A cross B, okay? So A cross B can be calculated as A, B sine theta with the vector n cap, where what is n cap? Because of this n cap, this whole quantity is a vector. And we know this is magnitude of A, this is magnitude of B, and theta is the angle between A and B, right? I'll also draw the figure for this. Now this n cap, this is a perpendicular vector to A and B. यानी कि whatever we get as the output of this A cross B will be a vector which is perpendicular to A and perpendicular to B. So the output of A cross B is a vector, right, which makes 90-degree with A as well as 90-degree with B. And based on that property, we have discussed this, yes, in the previous class also. Based on that property, I cross J, right? I cross J is equals to K, है ना? And J cross K is equals to I. So there were some properties, and we started with those properties in the last class. Let me define those properties as well. And first property which I would like to tell you is that A cross B is not equal to B cross A. Why? See, because the direction has changed. And in vector quantity, the direction matters a lot. So how can we write this? A cross B and B cross A has a minute difference, which is of direction. So if I write minus times of B cross A, that would definitely be equal to A cross B, right? So this would be the first property which which we should know. And this is a very important property. I mean, this is a very basic property, but important because see, while multiplying this, okay, I'll tell you the use of this as well. Oh my God, I should write it in. No, the properties are correct. If you have written this, that is correct. I'm just writing this in blue pen. A cross B is not equal to A hat. A cross B can be written as minus times of P cross A. This is the first one. And second is that A cross is a vector which is perpendicular A right. Yes. I think my network connection is poor. So in between, if I'm not audible, but right now there has to be some disturbance. And please raise your hand, okay? If you will raise your hand, I'll come and listen to you. Guys, am I no. Uh, guys, am I audible? Okay, cool. Yeah, I think I had a problem with my network connection. So that is why I was leaving the class. I mean, Zoom wasn't working. But please, if and in any case, if someone is not able to listen to me or my voice is distorting, then just raise your hand and I will get back to you. Okay. Or you can also drop me a message on chat. Right. Yeah. So second property was A cross B is a vector quantity which is perpendicular to A as well as B. Right. That we have already discussed. Now the third property is, so if A and B are two non-zero vectors, obviously we are taking two non-zero vectors, because if we are taking a zero vector, then what is the meaning of multiplication, right? Then multiplication will always be zero. So if A and B are two non-zero vectors and we say that A cross B is equals to zero, then it means that A and B are parallel. If you remember, if A dot B was zero, if the dot product of two vectors is zero, that implied that the two vectors are perpendicular. But in this case, if the cross product of two vectors is zero, it obviously implies that they are parallel to each other. Now, why they are parallel to each other? That is so I have given you the proof or the explanation for that. So if A cross B is zero, it means that A, that is magnitude of A into magnitude of B into sine theta into n cap is equals to zero. So somebody can, I mean, anyone of you can have this doubt. What is n cap, right? So n cap is a unit vector, first of all. And when we were studying unit vectors, I told you that what is the use of unit vector? Unit vector is just written to give the direction. So this n cap is here to give you a direction. Which direction? A direction which is perpendicular to A and B, right? Okay. So A into B into sine theta into n cap is 0, it means n cap is not 0, obviously, that is a unit vector. So either A has to be 0 or B has to be 0. Obviously, A and this are same, right? We can write it in both ways. So either A has to be 0 or B has to be 0 or sine theta has to be 0. But we already stated that these two vectors are non-zero. Hence, sine theta has to be 0. And sine theta is 0 when theta is equals to 0. Theta is equals to 0 means A and B both are inclined with each other at an angle 0 degree. Which means that both of them has to be parallel. Right? When two vectors are parallel to each other, they make an angle of 0 degree, right? So if the cross product of two vectors is 0, it means they are parallel. And if the dot product of two vectors are 0, it means they are perpendicular. Right? Okay. So let's come to the next property, which says, which basically uses this information. Okay. Next property is this. Let's start with this. So let's say there are two vectors which are perpendicular to each other, right? So if theta is equals to 90 degree, then observe what happens with A cross B. What happens with A cross B is A cross B becomes this into sine 90. And what is the value of sine 90? That is 1. So A cross B becomes A, B, n cap. Right? Now using the same property, you can observe these. I mean, using the using the third and fourth property, now you can make some rules. So if you want to find out cross product of two same vectors, that is, if you want to find out the cross product of I with I itself, that has to be 0. Similarly, J with J is also 0. Similarly, K with K is also 0. No? Because all of the same vectors make an angle of 0 degree with itself, and sine 0 is 0. So like in dot product, when we used to find out dot product of two vectors given in component form, we just multiplied their respective components. X वाला x के साथ, y वाला y के साथ, z वाला z के साथ, right? That is what used to happen in dot product. Just multiply the respective components. But in this case, the multiplication of respective components will always result in 0, right? Now, one more rule. I cross j is equals to k. Similarly, j cross k is equals to I. Similarly, k cross I is equals to j. And the order has to be same. How can you remember the order? I, j, k. Just write them in circular form and complete the circle. Now, if you start moving from I mean, complete the clock. This has to be in clockwise form, right? So if you multiply I with j, you get k, you reach to k. Then j into k, you reach to I. Then k into I, you reach to j. If you want to uh, take the opposite direction, that is, if you want to multiply I with k, then you are not reaching to j, but you can if you put a negative sign. I mean, you are just opposing the direction. So opposing the direction means you just have to put a negative sign here. So if I want to write what is I cross k, that has to be minus j, and so on. Right? Why? Why did this happen? Because if you are multiplying okay, I can explain one, and all others will follow the same strategy. Be a vector which is I, magnitude of I, magnitude of j, angle between them, which is sine 90, because I and j are perpendicular to each other, and a direction perpendicular to both of them, which is k. Now I is a unit vector. This is 1, this is 1, this is 1. This is just simple k, right? All others are also following. So guys, am I audible? Yeah, my network connectivity is too poor today. Okay. So I was explaining one more thing that let's say A cross B was AB sine theta n cap, right? But if I write what is the magnitude of A cross B, then n cap, magnitude of n cap is simple one, right? So magnitude of A cross B can be written as magnitude of B sine theta. Obviously, this is also magnitude of A. We could have also written this the same thing as this. Sorry, AB sine theta, right? Both of them are same. So using the same example, we can write this sine theta as magnitude of A cross B divided by magnitude of A into magnitude of B. Now comes two more really important properties which we will be using in some questions also. This will be the last properties that we are writing or that we are studying in Oh, no, 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 no. We will also, I would also tell some more properties like this. Which vector is given. You have to write this as A cross C plus A cross C. Right? B A plus C cross. This is these are not. So don't, if you write it in mm, uh, am I audible, guys? If I'm not audible, just raise your hand. If yes, then a thumbs up would be enough. Anyone, if I ask you, I mean, I would be asking you again and again. So whenever I ask, yeah, बस यही चाहिए इतना ही. Thanks. A thumbs up would be enough. Yeah. So yeah, sixth property was that cross product is also distributive, just like dot product, right? Then seventh property is, let's say, if two vectors are given, the first, I mean, we have understood how to define vector product, right? But if theta is not given, यानी कि angle between the two vectors is not given, then how would we find the cross product? So take this case, for example. In this case, we have a vector as a1 a cap and b1 cap plus b2 j cap plus b3 k cap, right? Then how do I find the cross product of these two vectors? So the basic thing that I want to is, if there are two vectors given in component form, how would I find their cross product? And if you've forgotten, I would like to remember IJK in the Uh, yes, I'm audible. So I'm solving this determinant for you, just for you to understand how did we get the cross product as this determinant, right? So your J will be A1, B3, A3, B1 minus A1, B3 plus K cap, and this would be A1, B2 minus A2, B1. So this is the cross product of these two vectors A cross B when given in component form, right? And do you know how did we get this? Just by simple multiplying these. If you multiply A cross B na, and you use these third and fourth, second and third property, which are this, yeah, these one. I cross I, J cross J, K cross K are 0. I cross J is K. Similarly, J cross K is I. K cross I is J. I cross K is minus J. I cross J, oh sorry, J cross I would also be minus K. So if you use these properties, you will get this result. But but as we know that if you use those properties and solve it, you will take a lot longer time, right? That is why this can be shortened to this just solving this determinant. Just always remember that in the top row you write ijk, in the second row you write your scalar component of first vector, this one, first vector, and then this is second vector. So this is first row and this is second row. Just always remember this, nothing more, right? So this is an important property, by the way. I would also mark the important properties. I should have actually. I did not. That is my mistake. This is an important property because this teaches you, this shows you how to find out how to find out cross product of two vectors. And in most of the cases, yeah. So A, the ninth property says both the properties are related, but let's first solve the eighth one, right? So eighth property says if A vector and B vector are two adjacent sides of a triangle, then the area of the triangle is equals to half of A cross B. Obviously, magnitude of A cross B. I mean, we are only calculating the area. Area must be a scalar quantity. Hence, we are calculating the magnitude of A cross B, right? But before this, I mean, first of all, this is important. This is an important property that if you know the two adjacent, obviously, every two sides are adjacent in case of a triangle. But if you know two adjacent sides of a triangle, or rather than that, if you know two sides of a triangle, then you also know the area of that triangle, right? Let's prove this. How is it true? So, yeah. Let's say this is a triangle, and this is A, this is B, this is C, this is your side A, this is your side B, right? And let's say this is vector A and this is vector B, and let's say this is angle theta between them. Then we are seeing that area triangle ABC is equals to half of cross product of A cross B and the magnitude, I mean, the magnitude of cross product of A and B, right? Now, how did we reach to it? So before that, can someone tell me how do we find out the area of a triangle? How do you find out the area of a triangle? We have been finding, I mean, we have been finding the area of a triangle for like seventh or eighth standard. There are various methods that we have used over the years to find out area of a triangle. We can find that out using base and height. We can find that out if we have all the length of the triangle, all the sides of the triangle, which was Heron's formula, if you remember. Then in 10th, we found the area of a triangle using coordinates in coordinate geometry, right? So we have uh, I hope I'm audible, guys. Yes, I think I am. Cool, 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 cool. No,
So I can tell the final thing.
I think we were on the eighth property while we were explaining that if we have two adjacent sides of a triangle, then we also know the triangle area of the triangle.
So can I say the formula?
Can you see the?
Can I see the formula?
The formula is half of magnitude A cross B. Right now, I
No,
do
it's
not
a
have.
normal triangle.
Okay, the formula for normal triangle, formula to find out the area of a triangle are, I mean, there are various formulae. Which one do you
For
want to know?
any triangle.
For any triangle.
It's like
It
half
depends.
BH sin theta, right?
Yeah, for any triangle. For any triangle, if we know the adjacent two sides, basically two sides, then it is true for any triangle, their area would be half of magnitude of A cross B. Magnitude of A cross B
Yes.
will be AB sin theta. Yeah, एक second. Yeah, so this is the formula. But how did we reach to the formula? So area of triangle ABC is equals to half base into height, right? Base we already know. Base is magnitude of B. Height is this BD. BD can be written as magnitude of A sine theta. And this whole thing is nothing but magnitude of A cross B. So if we know two sides of a triangle, we also know the area of triangle. And the same property can be extended to a parallelogram also. Ninth. Okay. Which is basically, this is also an important property, by the way. And it says that if A and B are two adjacent sides of a parallelogram, then area of parallelogram would be magnitude of A cross B. Because a parallelogram is made up of two triangles. These two triangles. But simple ही है, इसका भी कोई ज्यादा बड़ा लॉजिक है नहीं. इसका फॉर्मूला आपको नहीं पता होगा, चलो ये पता कर लो सबसे पहले. ये इंपॉर्टेंट बात है यहाँ पे. तो लेट्स से ये हमारे पास एक पैरेललोग्राम है ना. दिस इज ए, दिस इज बी, दिस इज सी, दिस इज डी. तो एरिया ऑफ अ पैरेललोग्राम होता है सिर्फ बेस इनटू हाइट. एरिया ऑफ अ पैरेललोग्राम इज बेस इनटू हाइट. If the area of a triangle is half base into height, then area of a parallelogram is base into height. Now, they are saying that this is A, This is B, this is angle theta. So the area of this parallelogram would be A cross B. कैसे? A cross B magnitude would be A B sine theta. So let's take this B as base. Then this would be your height. This would be your height. है ना? Let's call it AE. Okay. AE would be your height. Right? And the length of AE, if you find out, so in triangle ADE, your sine theta would be perpendicular upon hypotenuse, right? Perpendicular is what? AE. Hypotenuse is what? AD. So yahan se aap, you can find out that AE is nothing but A sine theta, which is written here. So half base into height, sorry, base into height can be written as base is magnitude of B and height is A sine theta. That is why the area of a parallelogram whose two adjacent sides are known to us can be given as magnitude of A cross B if the two adjacent sides are A and B, right? So these are some of the important properties that comes in vector product, and every question will be based on these properties only. So let's first of all find out some of the just some vector products of two vector. So you have to, if you're good with determinants, then it is not a tough task. Find A cross B where, so first part is A is equals to I plus J minus K and B is equals to 2I minus 4J plus 3K, right? So because this is first question, let's solve it with me. I want to find out A cross B. So A cross B would be determinant of I, J, K, then the scalar component of A, which are 1, 1, minus 1, and then the scalar component of B, which are 2, minus 4, and 3. So to solve this I cap, remove this the column and remove this row. 1 into 3 is 3, minus 4 into minus 1 is 4, minus J cap, then remove this, 3 into 1, minus 2, right? Plus K cap, and this would be remove this, minus 4 into 1, minus 4, minus 2. So the answer would be minus I cap, minus 5 J cap, minus 6 K cap. Just solve the determinant. Can you find this out? A is I minus K and B is 3J plus 2K. Everybody should try to do this. You know how to find out A cross B. Write the determinant properly. I, J, K. Write the ith components in this column, jth component in this column, kth components are in this column. I here, okay, the first, the scalar component of A are 1, 0, because there is no J, minus 1. Then there is no I, 0, 3, 2. which would be Ci minus 2j plus 3k. That should be the answer. I think the first one may be incorrect. Like that should be plus 3i. No? Plus 3i क्योंकि माइनस माइनस प्लस हो जाएगा. Yeah, cool. Let's solve another question now, which says find a unit vector perpendicular to a plus b and a minus b, right? Where a and b are where a is equals to 3i plus 2j plus 2k and b is equals to I plus 2j minus 2k. So first of all, we have to find a unit vector we can find out, right? First we find out the vector and then we will divide the vector by its magnitude. So that would be our answer, right? But for that, we need to find out a vector which is perpendicular to a plus b minus b. A vector